In this video, we're going to look at how to write a polynomial function when you're given the zeros of that polynomial function. So we're almost going backwards. And so here, it says we're going to find a polynomial function. We're going to call it f of x. We're going to say it's a third degree function with real coefficients that satisfies the given conditions, meaning it has these zeros, -1, 2, and 4, and f of 1 is 3. You could also write that if you don't like the function notation of knowing that this graph passes through the ordered pair 1, 3. And so the first thing we know is if we are given the zeros, we can write the factors, because if I have a polynomial function, let's say we have f of x, what we can write our function is, let's say I've got some scalar k, but I could write it in this form if a, b, and c are zeros of the function. So basically whatever the zero is, it's going to come after the minus sign. And so if I have, let's see, this -1, this 2, and this 4, let's just kind of write out what this would look like. So I'd have k, which could be some scalar, and this could provide some vertical stretch to our function. And so we have x minus a. Let's make our a the -1. And then I have x minus b. Oops, trying to be color-coded. X minus b. And then we have x minus our c value of 4. So we just basically use these as our a, b, and c value and kind of filled in the blank in this factored form of the function. Now, really the only thing we have left to do is this. We know that this minus a -1 right here can be rewritten as addition, so I'm going to do that real quick. Okay, and here's our function. Now, a couple of things, really only one thing we haven't figured out yet is we haven't figured out how to use this information. Okay, if f of 1 is 3, that would mean that that 1 is basically an x value and that 3 is basically a y value. So we have written a function that has these zeros, but we haven't yet ensured that it passes through this point 1, 3. And basically this point is going to help us find our k value. So if I think of the x, or the 1 is the x value, and the 3 is the y value. And we also want to think, we know that y is really just f of x. What I can do is I can substitute those values into the function that we have and solve for k. So I'm going to take that 3 and I'm going to substitute in for f of x, because it's like our y value. We're trying to figure out k, but then I have x plus 1 times x minus 2 times x minus 4. Hopefully you see that what I did is I just took this x, oops, let me back up a little bit. I just took this x value right here and I substituted in for the x's that are in our function. And now let's do a little simplification. So 3 equals k times 2, because that's 2, times -1, because that's -1, times -3, because that's -3. So 3 equals k times, let's see, that would be -2 times -3, that would be +6. And I'm kind of running out of room, so I'm going to I keep undoing everything. Let me, there it is. So we have 3 equals k times 6, and if you're just to solve that by dividing by 6 on each side, we'd find that k is 1/2. Now, after doing all that math and figuring out that k is 1/2, we now have everything we need to write our function. I'm going to come back to this function that we wrote right here. But now I'm just going to substitute the k into it. So our final answer is going to be f of x equals 1/2 x plus 1 times x minus 2 times x minus 4. And that's our function. So what we can do now is, if you want to check it, I'm just going to hop over to Desmos real quick. And so just to kind of prove what we just did and confirm, I'm using Desmos, and I graphed our function that we ended up at, including the scalar of 1/2. And we find that we have a function that passes through the point 1, 3, which we wanted, and it has zeros of -1, 2, and 4, so that we know we're correct. So here's our second example. Let's kind of play the same game, but we're going to use this idea of multiplicities. And so here it says we have a polynomial function of degree 3, so we have another cubic. with real coefficients that satisfies the given conditions. And it really only gives us one zero. It gives us just -2, but it says it's a zero of multiplicity 3, and then it gives us this ordered pair. So once again, I can think of this ordered pair as the ordered pair -1, 4, and that could be like a xy or an x, comma, f of x. But let me kind of write out our general form. We said last time that if I use k as the scalar, then I could write it as x minus a times x minus b. Since the cubic, we get a third one, x minus c, where these a, b, and c are the zeros. Now, this tells us that -2 is a zero of multiplicity 3. A way to think of that, it'd be like if that was a zero 3 times. So what that means to us is this. If I have f of x equals k, we could do x minus our zero of -2 times x minus another zero of -2 times x minus a third zero of -2. Because it has a multiplicity of 3, that means we see it 3 times. Okay? And so if I were to simplify a little bit, we basically have this. K, this becomes x plus 2. This is x plus 2, and this is x plus 2, and anytime we have those repeated factors, we could write that as x plus 2 to the third power. So here's our function, here's where we're at so far, and now we're to the step where we have to figure out the k value. So what I'm going to do is I'm going to play the same game as last time. I know that -1 is an x value and 4 is a y value, so I'm going to substitute those into our function. So if I know that 4 is a y value, and then we said that our x value is -1. And let's just solve with algebra and see where we get. So I have 4 equals k. -1 plus 2 is just 1 to the third power is 1 to the third power is 1. K times 1 is k. So we find that our k value is 4. So we're already ready to write our function. I'm going to take this form of our function, I'm just going to come up here, and we now know that f of x equals k times x plus 2 to the third power, okay? And so there's our function. The only place where this graph is going to cross the x-axis is at -2. And so just like last time, we can kind of confirm with Desmos, so I'll do that real quick. All right, now that we're looking at Desmos, we can see that I have my zero of -2, which we said. As a multiplicity of 3, which is what kind of causes this little wobble right here, but there's nowhere else that our function crosses the x-axis, and we know that it passes through that point that we were given, -1, 4. So it looks like the function that we came up with fits the given parameters.